Hello, this and my other YouTube videos are extracted from the History of Man series, currently 6 books published in print, ebook, and most importantly, audiobook. I'm a storyteller, and if you like these video stories, you'll love the History of Man series audiobooks. Great for commuting or just sitting back and relaxing. And unlike a novel you've read where you know the ending, you can listen to these books on tape more than once. There's so much to learn. Available on Amazon and audible.com, I narrate the audiobooks. And the best part about that is you can listen to these stories without having to look at my stupid face. And with that said, let's get the show on the road. Hello, John Bershoff with another episode of History of Man series. Today's subject, Global Warming 101, Part 5. In Part 1, we learned about normal global warming and normal global cooling. Part 2, we learned about temperature scales like Fahrenheit and Celsius and the invention of thermometers. In Part 3, we delved into some science, into radiocarbon radiometric dating of what are called proxy materials for constructing ancient temperature timelines, like carbon-14, the most famous, or uranium-235, and so on. The rhythmic decay and jettisoning of neutrons as beta particles can help scientists date stamp a proxy material. In Part 4, we then analyze those proxy materials. Well, what are they? They're like bone or ice cores. We analyze them for the temperature it had to be for those proxy materials to have such things as more carbon dioxide dissolved in the water, or more of a ratio of normal oxygen 16 to abnormal but not radioactive oxygen 18, and other examples to build our temperature timeline. We date stamp the proxy material, and then you look at the proxy material to figure out what the temperature was for that chemical reaction to have occurred. I need to bring in my grease board here. I don't like grease boards. I get grease all over me, but here we go. After the last ice age, Earth hit its sweet spot of 57 degrees Fahrenheit and 280 parts per million of carbon dioxide in the atmosphere. From 20,000 BC, when the Ice Age ended, to 10,000 BC, Earth warmed 10 degrees Fahrenheit. From 47 degrees Fahrenheit to 57 degrees Fahrenheit, or 1 degrees Fahrenheit for every 1,000 years. Now remember that, 1 per 1,000 years. 57 degrees is Earth's sweet spot, at least for this interglacial period. And that graph is shown here. End of the Ice Age, 20,000 BC, Earth slowly warmed over 10,000 years. It warmed 10 degrees Fahrenheit, or 1 degrees Fahrenheit per 1,000 years. That's important. It's a slow process. Now, using paleoclimatology stuff like this, global temperatures and carbon dioxide parts per million have been plotted. And here are some examples. From about 250 BC until 400 AD, when the Roman Empire was at its zenith, the Earth experienced a warming period, even dubbed the Roman warming period or the Roman climactic optimum. Average global temperatures rose from the 57 degrees baseline, perhaps up about 1.5 degrees Fahrenheit, peaking around the time of the ministry of Jesus, and then dropping back down to baseline. It took 300 years to go up 1.5 degrees and another 300 years to drop back down. And that's shown right here in this solid line. This is the Roman warming period. 300 years, 1.5 up, 300 years, 1.5 down. Now, the explanation for the Roman warming period was likely weather patterns on the sun, more solar radiation and heat and energy striking Earth. You know, the sun has weather patterns too. Now, things remained fairly copacetic for about 600 years. Then slightly before the time of the Normans of France, conquest of Britain, around 900 AD, after the Muslim world had achieved its cultural zenith, Earth entered another warming period, dubbed the medieval warming period, that lasted until 300 AD or 1300 AD. And then global temperatures rose another 1 to 1.5 degrees, dropping back down a 400-year span, 400 years for average global temperatures to rise 1.5 and then drop back down. And that's this dotted blue line. This is the medieval warming period. 1.5 up, 1.5 back down. It's a slow process. Now, the cause of the medieval warming period was again attributed to solar weather patterns. Plus, it is believed there was actually less volcano activity on Earth at that time. Volcanoes put dust into the atmosphere and it kind of blights the sun and it can cool things down. The Roman warming and medieval warming were also partly due to previously discussed variables, the Milankovitch variables, discussed in one of the other history of man things we did about global warming, so you should watch these in order. But those Milankovitch variables, one is the solar orbit or the eccentricity of Earth around the sun. You know, the Earth goes around the sun slightly off center, but it also has a slight eccentricity. Every 100,000 years, it sort of goes back and forth around the sun, its solar orbit. There's also the Earth axis tilt or obliquity. And I'll move this for a moment. I mean, Earth is tilted on its axis. And we take it to be about 23.5 degrees. But it doesn't stay like that. It kind of goes back and forth. It's called its obliquity. And that happens about every 43,000 years where it makes a full back and forth on the axis tilt. And then there's the wobble of the Earth called the precession. It's like a top you spin and the top starts losing its energy and you see a little wobble in it. Well, the Earth is not losing its energy, but there is a slight wobble to the spin, and that's called its precession. Now, those three things, when they properly align completely, they can trigger a real ice age, to be sure. But when they somewhat align, they can also align enough to create normal warming trends and normal cooling trends like the medieval warming or the Roman warming period. For instance, they can also trigger cooling trends. The medieval warming period, things kind of, right after things kind of cooled down. They actually went down below baseline, termed the Little Ice Age. And so global temperatures dropped 2 degrees Fahrenheit below normal to about 55 degrees, and then returned to baseline in the 1800s. So from about 1300 AD to 1850 AD, a 550-year Little Ice Age occurred on Earth, ending at the beginning of the Industrial Revolution when human activity started dumping carbon dioxide in the atmosphere. And again, it's important. Now, here is that Little Ice Age. It goes down 2 degrees, and then it goes back up 2 degrees. But it's a slow decline in temperature and a slow rise in temperature. And it's important to understand that the rate, when you have a huge planet like Earth, things don't change quickly. Earth has lots of buffering systems. Otherwise, life would not have taken hold on our planet. Life depends on consistency. It won't do well with rapid changes. Sure, there have been some catastrophic ones, like the asteroid that struck and doomed the dinosaurs into extinction. But otherwise, these processes are slow. They don't occur abruptly. So those three epochs, the Roman warming period, the medieval warming period, the Little Ice Age, they're often misrepresented by climate change deniers as proof the Earth goes through periods of warming and periods of cooling. Well, of course it does. We know that. The thing about climate change deniers that they fail to grasp, or if they grasp, they aren't telling you it, is that these epochs, they occur slowly over periods of time. They aren't rapid. They're slow rises in temperature and slow declines. Things they creep up and then they creep down. So what is the lesson to be learned here? The main lesson about understanding abnormal global warming and climate change. The lesson is the rate of change, baby. It's like Vince Vaughn, Las Vegas, baby. It's the rate of change. It's too fast. So, but before we hammer that rate of change that we're currently visiting with right now, I want to talk about some other examples of global warming besides temperature and carbon dioxide levels. The ice sheets, they're melting, baby. The rise in sea level, it's rising, baby. So according to NASA, the Antarctic ice mass is melting at a rate of 150 billion tons per year. According to NASA, the Greenland ice mass is melting at a rate of 270 billion tons per year. You know, although some areas of the Antarctic ice mass have actually increased in thickness, and climate change deniers like to point to that small area, the overall picture of the Antarctic ice sheet is not pretty. I'd say it's rather icy or ice cold facts, but that is just it. It's not as icy. It's less icy. What about sea levels? Even though systems on Earth, such as life, make water, the water we have on Earth is pretty much a closed system. When Earth formed, it grabbed all the water it could, more than its fair share, and it's a closed system. For instance, the biblical narrative of Noah's Ark is cute and all that, but it was impossible to have occurred. All Earth's water is either in the oceans and seas and lakes, and quite a bit in the north and south ice sheets. There ain't no more water on our planet. If all the ice melted, the sea levels would rise perhaps 150 feet. That means all the ice melted, flooding coastal areas, but certainly not covering the entire Earth in a deluge. Not even foothills would be covered, let alone mountaintops to be covered with water. Not enough water on our planet. Sorry, Noah. We know during the last ice age, when even more of Earth's water was locked up in the ice sheets, the sea levels were lower. A person could walk from Africa through Europe and across Britain and go into Ireland and come back into Britain and come over to France walking and walk across Asia through India, China, and up into Russia and cross the land Bering Bridge into Alaska, North America, and walk all the way down to the southern tip of South America, to the southern tip of Chile, to Tierra del Fuego, land of fire, so named by Magellan, and never get their feet wet. A person back then, during the last ice age, could walk all over the planet, all the continents, and never touch water. In the Americas, the indigenous peoples actually entered in waves 30,000, maybe 50,000 years ago, before the sea levels rose and that Bering Land Bridge became covered with ocean water. When the ice age ended, the sea levels rose. The land bridge disappeared. It is now called the Bering Strait. Ireland became separated from Britain and Scotland, which became separated from France. The rising sea levels even gave us Darwin's Islands, the Galapagos Islands off Ecuador, that then forced his finches to speciate down slightly different evolutionary lines depending on the island they inhabited. It was once one large mass, but as the sea levels rose, as the ice age ended, they became a dozen or so separate islands, forcing those finches to speciate differently. This is the basis of Darwin's evolutionary theories, or at least one of the bases. Now, we also can do just direct measurements. Sea levels have risen 6.5 inches since 1950, and half that, 3 inches, past 20 years. Now, there's no data over millions of years about sea level rises and falls like there is for temperatures and carbon dioxide in the atmosphere. But coral reefs come to the rescue, and they oddly help with analyzing ancient sea levels. You see, coral reefs need to be almost precisely a certain number of feet below the sea level, to get their sunlight. Too deep, and they cannot do what they need to do to stay alive as an ecosystem. It likely has to do with less solar energy. So analysis of coral reefs over the past 50 years show they are in rapid decline. But going deeper into the sediment, into the floor, proxy core samples that are then dated, the decline from normal sea level changes over thousands of years have occurred in those ecosystems, in those coral reefs. But those declines have been slow to their demise and then slow to reoccur again. The point is, normal ancient rising sea levels from ice ages that have ended, as well as current abnormal rising sea levels, adversely impact coral reefs. When it is normal sea level rise and fall, changes are slow to come about. When it is fast, like right now, and abnormal, well, coral reefs decline is fast. It's too fast. Regardless of the coral reefs, all you have to do is just really measure the sea level, the rise directly with a ruler as proof. 6.5 inches rise in 50 years, this big ocean, we're 2/3 ocean, 6.5 inches, that's a lot of water. And where is it coming from? We're in a closed system here. Where is all that water coming from? The rise in sea level. Well, we know where it's coming from. Melting ice sheets. It can't come from anywhere else. And the ice sheets melt because they're warmer, because of global warming. It doesn't take much math to figure this out. So, in summary, under normal conditions, Earth ice house and Earth hot house are slow processes. Earth atmospheric carbon dioxide, greenhouse gases change slowly up and down. Earth sea levels change slowly up and down, all of which are directly connected to glaciation on the one hand and interglacial warming on the other hand, and those Milankovitch variables I talked about. But the current climatic changes are too fast, over 50 years. The rise in global temperature of 1.8 degrees Fahrenheit right now, from the sweet spot of 57 degrees Fahrenheit to 58.5, is anthropogenic. It's this red line right here. It's gone up way fast, faster than this Roman warming period, this medieval. And it has an arrow on it because it appears that it's going up. And anthropogenic means this rise in temperature is human caused. That's what anthropogenic means. Carbon dioxide from fossil fuel burning. The rise in atmospheric carbon dioxide, that rise of 140 parts per million from the sweet spot of 280 parts per million to the current 420 parts per million, that's a quick rise in just the last 50 years or so. Again, anthropogenic. The rise in sea levels of 6.5 inches, well, that can only come from one place, melting ice caps. The melting ice caps, they're at an alarming rate. You just have to look and measure them. So what's the take-home lesson here? It is the rate, baby. Again, Vince Vaughn. It is the rate, baby, the rate of changes of temperature, of carbon dioxide in the atmosphere, of sea level rise, of melting ice caps. The rate is alarming, and there's nothing in the history using date stamping proxy materials and other ways of verifying it that has happened this quickly. This is abnormal and alarming. I hope you enjoyed this History of Man series episode. The History of Man, this is the first book, the first History of Man. I have 6 books out now. I'm writing more. It's a style of writing called jumping off, where I start with a baseline subject, which is medicine and science, and I jump off into other things: history, geology, astronomy, art, music, sports, you name it, famous people. But I always come back, and then I jump off again and come back to the baseline. It's a style of writing that may not be for everybody, but it's an interesting style of writing, and I promise with the turn of about every page, you'll learn something. I did. The books are available in print, in e-Kindle, in audiobook, and I do the narrating. Anyway, thank you very much for listening. I hope you enjoyed the series on Global Warming 101. I hope you're well, and have a good day. Thank you.